Suppose we had, say, the student class and an employee class. Now, as you may suspect, these two classes have a lot in common. For example, a student has a name, while an employee also has a name. Student has a year of birth. Employee has a year of birth. Student should have an email. Employee has an email. Student should have a phone number, even if it's a home number. And employee should have a phone number. However, they're different in their ways. For example, students have, like, for example, a grade level and a GPA. However, employees have, say, a salary and an occupation. Basically, student and employee are definitely classes that would be different enough to be different classes. However, they're similar enough that we may want to do something about that. And the solution is, first notice that student is a person and an employee is also a person. So suppose we had a person class that contains a name, a year of birth, an email, and a phone number, like so. And now, if we can somehow get student and employee to build off of person, then we wouldn't have to copy as many things like name, year of birth, email, phone number. This type of relationship is called inheritance. So first, for example, if we have a class named person with a name, email, phone number, and a year of birth, and the constructor that sets them using parameters, like that, and then just say a display method. Like that. So that's a working person class. And now, let's say we have a student class. We have our student class right here. However, we don't want to create another name, year of birth, email, and phone number. That's kind of, the person already has that. We don't want to create another copy of that. That's kind of wasteful. Therefore, we can do something called inheritance. Basically, we have student extend person, so class student extends person, like that. So now, by doing this, student automatically contains all variables and methods of person. So name, email, phone number, and year of birth are automatically put in student. And display methods also put in student. And now, student has additional variables I can create, like a grade and a GPA, like that. And now, of course, our student class is not complete yet because we don't have a constructor. Now, the thing is, constructors are never inherited. We must create our own constructor in student. So, for example, first of all, student contains the name, email, phone number, and year of birth variables. Therefore, we must have that name, year of birth, email, and phone number are parameters, because otherwise there's no way to construct that information of the student. And then next we have our grade and our GPA. So we have something like this. Now, one other advantage of inheritance is that basically we can call the constructor of our superclass. And as a matter of fact, you must call the constructor of the superclass in a subclass, where the superclass is person and the subclass is student. So remember, subclass extends superclass. And how do I call the constructor of person? Well, basically, remember that when we called a constructor of the same class, we used this and then the parameters. Well, to call a constructor of a superclass, instead of this, we do super. And then inside the parentheses, the parameters. Now, we can pass the name, the year of birth, and the email, and the phone number. And the nice thing about that is that when we pass it into the person constructor, it automatically sets the name, year of birth, email, and phone number. However, we can still do additional stuff. So grade equals G, GPA equals G1. Like that. Now we have a working student class. So now if we have student S1 equals new student name year of birth, email, phone number, grade, and GPA. So something like that. And everything works. So for example, if I print s1.name, it'll be name1 because first of all, student contains a name variable because it inherits it from person. And then student sets the name variable once I call the person constructor. And similarly, year of birth works, email works, phone number works, and finally, the additional variables I introduced into student, grade and GPA. So grade, that works because when I call a constructor, it explicitly sets it, in this case to 10. GPA works for the same reason. And just like all variables, it also inherits all methods. So basically, for example, person has a display method. Well, now student also has a display method. So s1.display. And it's exactly the same as the person's display method. So now when I run, it's going to display this information. Now you may notice that this doesn't include the grade and the GPA. Why is that? The reason is that person's display method only gives the name, year of birth, email, and phone number. There's no way of including grade and GPA when not every person has a grade and GPA. Now, sometimes we may want the display method to display the grade and the GPA as well. So how do we do that? Well, we can do something called overriding a method. So basically, what this is basically creating a method with the same name and parameter types as the superclass. And of course the same return type, because it has to be the same method. And then now that replaces the superclass's method. So for example, public void display. So if I copy this into there and I include the grade and the GPA, Then now when I call the display method up here, it shows all the information: name, year of birth, email, phone number, grade, and GPA. Now, this raises a question. Do we actually have to copy all this code right here? Because really though, if you think about it, all I'm doing is calling the display method in person and then adding 2 additional statements. Now, of course, you can't just do, for example, display. That's going to cause an infinite loop. How do I instead call the person's display instead of the student's display? Well, I can do something called super.display. So what that does is basically it calls the superclass's display method. So not this display method, which is absurd, but instead this display method. So therefore, whenever I call display method of student now, it'll call super.display, which calls this display method, name, year of birth, email, and phone number. Then afterward, the 2 other statements that I added. And it works as shown below. And of course, you can add additional methods, just like additional variables, without overriding. So like, for example, public Boolean honor roll return GPA greater than or equal to, say, 3.5. So in this case, honor roll would be true. Notice that student has the honor roll method and the grade and GPA variables, but person doesn't. On the other hand, person has name, email, phone number, and year of birth, which is inherited by student. So in other words, student, which is the subclass, inherits everything from person, so it contains everything that the person contains, except for the constructor. And then it also contains additional variables or methods potentially. And it can also override methods like the display method here. And it can also call the superclass display method. And in the constructor, you have to call the superclass constructor right here using the super. And you can add additional stuff. One last thing to note about this student class is that basically I cannot do any statements before the super call. Even a simple print statement won't work. Basically, in other words, the super call must be the first statement of the constructor. Similar to how this calling the other constructor of the same class must be the first statement of the constructor. You can have comments, but you can't have other statements. Here's an exercise. Do the same thing with employee. So for this one, again, class employee extends person. This time, double salary, string occupation. And then, of course, a constructor. Again, it needs to take in name, year of birth, email, phone number, and this time salary and occupation. And again, just like the student class, I can just do super of n, y, e, p, setting the name, year of birth, email, and phone number variables, and then salary equals s, occupation equals o, like that. And for the display method again, super.display, just like the student class, and then additional stuff to display like salary and occupation, like that. And now our employee class will work. So for example, something like this, and it'll work. Here's another example. So here we have, for example, a rectangle class, a length, a width as instance variables, the constructor that sets them, and an area method. Like that. And now, suppose we wanted a square class, because a square is a special case of rectangle. The square class would inherit both length and width, because a square does have a length and a width, they just happen to be equal. And then, so we don't need the length and the width variables, the square automatically inherits them. The constructor, we need, and this time we only need to accept the length, because the square is determined by its length. Then afterward, how do we call the superclass constructor? In this case, we need to make sure that the length is equal to the width. So how do we do that? Super L comma L. So now the length is L and the width is L, right here. And of course, don't forget that we need to put the extends keyword, so class square extends rectangle, because if you don't, then all of this won't make sense. So now everything works. So square now has a length and a width variable and a constructor that takes one parameter and then sets the length and the width to that parameter using the rectangle constructor. It also has an area method that's directly inherited from rectangle. Notice that, however, square does not have a 2-parameter constructor. You cannot construct a square with 2 parameters. So square sq1 equals new square 7. I try printing the area, it's going to be 49. Because the length and width are going to be set both to 7, so the product's going to be 49. So this is an example of an inheritance relationship where the square, which extends rectangle, actually doesn't have additional variables, but it still works because sometimes I might just want to deal with squares. So if I use that a lot, it might be useful. And another thing, the constructor accepts fewer parameters than the rectangle constructor. This is allowed because I don't have to accept both the length and the width if I know that they're just going to be equal. I can just accept the length and the width is automatically determined. Now, this raises a question. What if, say, a class right here I have doesn't have a specifically defined constructor? Then I have a class B that extends A. Then, doesn't need a constructor? In this case, no. To explain this, basically, when we don't define a constructor, it's equivalent to having an empty constructor. So public A and then nothing inside. Similarly, when we don't have a constructor in B, it's equivalent to having an empty constructor. Like that. And now, we don't have to call super in this B constructor. Why is that? Well, it turns out when this superclass has a constructor with no parameters, super doesn't have to be called. Basically, super is by default called whenever I have a superclass that has no parameter constructor, but I don't have super. So it doesn't matter here whether I have super or not. It's going to automatically do it. Now, what if I do stuff in this constructor? Like setting the variable to 7. And now over here var2 equals 9, for example. Now what happens if I do something like say b1 equals new b, and then I print its variables. It turns out both of them are going to be modified. So basically when I create a new b, the following happens. So first I call the constructor. That's what this thing right here is. It takes no parameters. And the first thing it automatically does is, since b extends a, the constructor of b automatically calls the super. Notice we're allowed to have no super because the A class has one that has a constructor that has no parameters. On the other hand, if its constructor had a parameter, say int n, this would not be allowed. I would need a super. But it just happens that A has no parameters in its constructor, or at least in one of its constructors. I can have another constructor that has parameters. That doesn't matter. The thing is, if I don't call super, it's going to automatically call the no parameter constructor. Now, back here on square, however, we have to call super, and the reason is because rectangle does not have a no parameter constructor. So then back here, we constructed that thing. So it calls super automatically. It's equivalent to having super right here. It's the same result as shown below. So what super does is calls the default constructor, basically the constructor with no parameters, sets var1 to 7, hence this thing is 7. Then afterward it sets var2 to 9 in the b's constructor. So therefore everything's set to 7, 9 in the b class. Now it doesn't matter if you call super or not, if you mean to call the no parameter constructor, but it matters a lot if you plan to call, for example, the constructor with parameters. So this constructor, for example. If I do no super and just do, say, var2 equals b, and that's it, no super, then I create one of these, so b2 equals new b, 5, 7, then I print these. Then it's going to be 7, 7, because when I don't call super, it's going to automatically go to the default constructor, which means that var1 is set to 7. However, when I do call super with no parameters, it's the same result. When I call super with a parameter, however, that's when it calls the constructor that matches. So it calls the constructor with one parameter in this case, and it'll properly set var1 to 5 and var2 to 7 as shown below. Now here are some more exercises. Determine whether the following inheritance relations are valid or not. So the first one, square extends rectangle. Well, we know very well that that works. In fact, we literally have right here square extends rectangle. It's good. It's a good relation because square is a special case of rectangle. Basically, every square is a rectangle, but not every rectangle is a square. A square is a rectangle, basically. Or in general, an A is a B implies A extends B is valid. And A is a B usually implies A extends B is valid. So rectangle extends polygon. Well, is every rectangle a polygon? Yes. Rectangle extends square? Well, is every rectangle a square? No. In fact, square extends rectangle, so rectangle should not extend square. Is every rectangle a rectangle? Yes. However, is rectangle a special case of rectangle? No, it's just itself. You shouldn't extend yourself. Like, if a class extends itself, that's not allowed. It's pointless as well. Oval extends circle. Well, is an oval a special type of circle? Is every oval a circle? No. Is every circle an oval? Yes. Rectangular prism extends rectangle? Well, is every rectangular prism a rectangle? Simply no. Even though rectangular prism might just be a rectangle with an additional height, it doesn't, like, Java would allow it, but it really doesn't make that much sense because rectangular prism isn't a special case of rectangle. One is 3D and one is 2D. It just doesn't make sense. Sphere extends circle, same reason, no. Cube extends rectangular prism, that is yes. Because every cube is a rectangular prism, cube is a special case of rectangular prism. Person extends employee, no. Because person is not a special case of employee. There are people that are not employees. Student extends employee, no. There are students that are not employees. Bedroom extends house, no. That's not what the word extends in Java means. Extends doesn't mean contains. Extends means it is a relationship, means a special case of. So a house is not a special case of a bedroom, so no. And then vehicle is not a special case of engine, no. And then vehicle is not a special case of car. There are vehicles that are not cars. But car is a special case of vehicle. Every car is a vehicle. Truck is also a special case of vehicle because every truck is a vehicle.